Bismillahirrahmanirrahim. Assalamu alaikum, students. So, the lecture today is about the work, energy, and power. So, in the last lecture, we have already studied something in chapter number 10, and those things were like system. We have studied about the system, which you know that a small portion of the universe is called system. And then we have studied the energy. So, in energy, we have studied about the kinetic energy. So the kinetic energy is equal to half mv square. And also we have studied different forms of energy. Different forms of energy. So in different forms of energy, we have studied the kinetic energy, potential energy, and this potential energy can be gravitational or elastic potential energy. And we have a chemical energy. And then we have a thermal energy. And then we have nuclear energy. So these are the kinds of the energies which we have already discussed in the previous lecture. And also we have discussed the work kinetic energy theorem. So in work kinetic energy theorem, you have studied that W is equal to delta K. Delta K is equal to Kf minus Ki. Kf is the final kinetic energy minus initial kinetic energy. So you can write this equation like this one, mvf square minus 1 over 2 mvi square. Also, you can change this equation in vector work form. F into D is equal to 1 over 2 mvf square minus 1 over 2 mvi square in this form. So we will use these formulas to solve the problems. Now we have a potential energy, and this potential energy is gravitational potential energy. So in gravitational potential energy, you remember at high school level that this is equal to mgh, or you can write it mg delta y. So delta y mean the change in the vertical positions. So mg into y final minus y initial. You can write it like this one. And also in the previous lecture, we have studied that elastic potential energy, and that is equal to 1 over 2 kx square, where k is called the spring constant and x is the change in the length. Okay, after this, now we want to study about the potential energy, but the relation of the potential energy with the work done. So actually potential energy in the last lecture, I have explained that it is actually the stored energy. Potential energy is a stored energy. Stored energy. So stored energy means if you lift the block and the block is here, then the energy is stored. And that stored energy is called potential energy. And this potential energy can be converted into kinetic energy. If the block is falling down, then the potential energy is decreasing and the kinetic energy is increasing. So it can be converted into kinetic energy. And if the block is falling, and surely its thermal energy is also increasing. So after this, we have two concepts. One is the conservative forces and one is the non-conservative forces. So conservative forces are what? So in your book, it is written that conservative forces are those forces that can store useful energy. So conservative forces can store useful energy, useful energy. So the examples are given, the gravity and the elastic forces. These are the conservative forces. Also, we have electric forces, um, like due to charges, and the magnetic forces due to magnetic poles. So all these forces are also conservative because we can use them for useful energy. Okay, there are another kinds of forces that are called non-conservative forces. Non-conservative forces. So non-conservative forces are like frictional forces. Frictional forces are non-conservative, and also the air resistance. This is also non-conservative forces. It means it cannot be used for useful energy. So because when two objects interact and via frictional force, energy is not stored. So in this case, no energy is stored. Energy is stored. But here, energy is stored. So that's why it is called conservative and this is called non-conservative. Okay. But here in mostly we are studying the gravity and the spring forces. So now we want to develop a relation between work done and the potential energy. Now let's see what is this one. So work done and potential energy. Okay. So we have a body. Here is a block and we lift the block with some force, and that force is the external force. If the force is external, then work done is equal to delta UG. We write like this one. But if the work done is due to gravity, then it will be minus delta UG. So work done, you can write this equation that delta UG mean UF final minus UI initial, change in potential energy. Basically, this is change in potential energy, change in potential energy. So we always measure the change. We cannot measure the potential energy. We always measure the change in potential energy. So work done is also same F into D, and this is equal to UF minus UI. If you want to find the final potential energy, then it will be F into D plus UI. So you can write this equation in this form, or you can write this equation F is equal to mg here, because the force is the weight, in this case, the weight of this block. So you can write this one mg, and instead of d, you can write here delta y plus ui. So uf is equal to mg delta y plus ui. You can also write this one. So you should remember here that I'm talking about the external force. If the force is external, then we use the formula W is equal to delta UG. But if the force is the gravity, then W is equal to minus delta UG. If the force is gravity. Okay. So remember this one. Okay. Also, we can write the equation in this way. So at high school level, you remember that you are studying that potential energy or gravitational potential energy is equal to mgh. Or here we can write it is mg delta y. So if y initial is equal to 0, then surely there will be some yf. So we can write this equation mg yf, or you can write it mg y. Yf is y, and that's why we write this equation mgh. So y is equal to h. So it means the gravitational potential energy totally depends on the height. So if you increase the height, then it will be increased. Okay, so last time I already explained that the inclined plane is very important. So in inclined plane, this is the height and the ball is falling down with an angle theta. So what you will do, you will see that here is the maximum potential energy. This is mgh. And when it goes down, the whole potential energy is converting into kinetic energy. So according to law of conservation of energy, so potential energy is converting into kinetic energy. So what we will do, if we want to find the speed at this point, then we can write this equation in this way: mv square is equal to mgh. So m will cancel with m. So v is equal to 2gh under root. Sometimes h is not given direct. So it is length is given. This length is given. You can apply the formula h over L is equal to sine of theta. So the complete formula will become L sine of theta. So V is equal to 2G L sine of theta under root. You can write like this one. But if H is given direct, then you will put the direct value. Okay, after this is all about the gravitational potential energy. Now we have a potential energy of the spring mass system. So remember, just in the spring mass system, if we have a spring like this one and it has a mass m, and you compress the spring, it is like this one. So this is its original position, this is its compressed position, and this is this is x or delta x. So we can write the formula for elastic potential energy is equal to 1 over 2 kx square. X is this distance or this length, and k is the spring constant, and already you have found the spring constant in Kanune-Hooke lab. So where you have put the spring like this one and put the and different masses and measure this value of the change in the length. So if we want to see the graph of this potential energy, mean this elastic potential energy U, if I'm saying this is U and this is X, then its graph will be like this one. Remember this one. And also the graph of kinetic energy and V square. You know that kinetic energy is equal to 1 over 2 mv square. So kinetic energy is proportional to V square. So if we see the graph of this one, kinetic energy, it is also like this one. So these are the same graph, but this is elastic potential energy and this is kinetic energy. Okay. After this, now we have law of conservation of energy. Law of conservation of energy. So in law of conservation of energy, the total energy is always constant. So total energy mean this is called delta E. But here we are discussing only two kinds of energy. One is kinetic energy and one is potential energy. But there are other energies like thermal energy, chemical energy. But we are not considering that energy, but we are considering only two kinds of energy. So kinetic energy, delta K, change in kinetic, plus delta U, and this is equal to delta E. According to law of conservation of energy, the total energy is always zero, always constant. So in an isolated system, the delta W is equal to zero. So this is also equal to delta W, or W you can write. So in an isolated system, delta W is equal to 0. So delta K plus delta U, and this is equal to 0. So you can write this equation Kf minus Ki plus Uf minus Ui, and this is equal to 0. So Kf plus Uf is equal to, this will go in this side, Ki plus Ui. So you can write this equation in this form. So this is important relation. So after this, we have energy in collisions. Energy in collisions. So in previous chapter, we have studied about the collision, but we have studied about the inelastic collision. So inelastic collision was what? I just write here, inelastic collision. So you should remember that inelastic collision, the momentum remains same, but the kinetic energy not same. So we have developed a relation. If in this is one-dimensional case, if two balls collide with each other, okay, suppose this is this block and it is moving in this direction, and after this collision, the two blocks, this is M1 V1, M2 V2, this is M1 M2. After collision, the two blocks stick together. The two blocks stick together and then move with the common velocity. Then we have developed a relation that is V is equal to M1 V1 plus M2 V2 over M1 plus M2. We can solve the problems by using this formula. But if the collision is not inelastic, it is elastic collision, then how to solve the problems? So first you should know that what is elastic collision. So elastic collision is in which the momentum remains same and kinetic energy also remains same, both same. So we can write the equations. If we have two balls, so M1 V1 plus M2 V2 before collision is equal to M1 V1 dash, dash mean the different velocities, M2 V2 dash. This is after collision, this is before collision. And same is the kinetic energy. Kinetic energy is half M1 V1 square plus half M2 V2 square is equal to half M1 V1 dash square plus half M2 V2 dash square. So after solving these two equations, we can find the value of V1 dash, we can find the value of V2 dash. So I'm not solving by or deriving this relation. You should remember direct this formula. V1 dash is equal to M1 minus M2 over M1 plus M2 into V1 plus 2M2 over M1 plus M2 into V2. So you can apply this formula, and V2 dash is equal to 2M1 over M1 plus M2 into V1 plus M2 minus M1 over M1 plus M2 into V2. So you should use these formulas. But here, if the block is moving and this block is at rest, if it is at rest, it means V2 is 0. This is M1, V1, M2, V2. Okay. If V2 is 0, then this vector will 0 and this vector will also 0. So V1 dash is equal to what? M1 minus M2 over M1 plus M2 into V1. And similarly, V2 dash is equal to 2M1 over M1 plus M2 into V1. So you will use these two equations to solve the problems. Okay. So this is very important, and this is elastic collision. Here, momentum and kinetic energy both remain same. So the last article in this chapter is, that is a power. So power unit is watt. So remember this one. It's watt in normally in electricity we are using the watt. So the first, what is the definition of power? So rate of doing work is called power. So power is equal to work done divided by time, and work is equal to joule and time is second. So it means joule over second is equal to watt. One thing. So work and energy have the same units. So you can write the work is equal to energy over time. You can write like this one. Energy can be potential energy, mgh over time. You can use this one also. But also we can uh, write the formula in another form, that is power is equal to work done over time, and work is what? F into D over time, and D over T is what? So D over T is actually V. So power is a scalar quantity, but its complete formula is FV cos of theta. Like work is equal to FD cos of theta. So you should remember that this one, that actually power and work both are scalar quantities, but force and velocity are vector. But this is not in your syllabus. Actual formula is F dot V. So when we open this formula, it is FV cos of theta, and same is F dot D. So when we open, this dot is not like a point dot, it is dot product of two vectors. So FD cos of theta. So in this way, these formulas comes. One thing. The second thing, what unit we are using for electricity, like 40-watt tube light or bulb or anything. But if the things are rotating like motors or engines, then the unit is horsepower. So remember, horsepower, the unit is used in engines or motors. So 1 horsepower is equal to 746 watt. So you should remember this one. Okay. So this is all about your this chapter number 10. I think you understand. And next class, we will solve the problems of chapter number 10. And these are important things. Okay. Okay. Assalamu alaikum.